In today's digital and RF printed circuit board designs, demands for increased performance and decreased costs continually challenge engineers, designers, and product development teams across the nation. In most cases, the method of lamination used in the PCB manufacturing process can be key to supporting both high performance and optimizing costs. At Transline, we pride ourselves in being a technology leader in PCB lamination. We help our customers navigate through design for manufacturability issues every day. During these interactions, we came to realize that our customers desired a way to shortcut through these massive amounts of data available to help them make these critical choices. For this reason, we've put together this presentation to give you a general overview of the types of lamination processes available and how each one has an impact on performance and cost. Therefore, we proudly give you Optimizing PCB Performance and Cost through Lamination, Methods, Applications, Performance Impact, and Cost Impact. In a very general sense, there are four major types of multi-layer lamination used in PCB fabrication today. The first type is standard lamination. Standard lamination is typically used in low-frequency digital designs. Standard copper-clad FR4 laminate is used, and pre-preg is used to bond the layers together. The second type of lamination is hybrid lamination. Hybrid lamination is used in designs that have a combination of low and high frequency layers. Some layers may be standard FR4 material, and other layers are typically a high-frequency RF laminate. RF laminate is more costly than FR4 and more challenging to use. By using the high-frequency material and bond ply on a limited number of specified layers rather than the entire board, the cost is effectively lowered while increasing performance over standard material and lamination. The third type of lamination is FEP lamination. FEP is a very thin, 1 to 2 mil thick thermoplastic bond ply. It is always used in RF and very high performance applications. It is only used between high performance materials that match its properties. It has a decay of 2.15 and has a dissipation factor of 0.0005. FEP film is very high performing, but is expensive and very challenging to use for manufacturers. For this reason, very few PCB manufacturers offer this option. The fourth type of lamination is fusion or direct bonding. Fusion or direct bonding is only used in the highest performance applications. In fusion bonding, only very high performance Teflon PTFE material can be used. In this type of lamination, no pre-preg or bond ply is used to bond the layers together. Rather, the material is self-bonding when subjected to very high heat and a very lengthy, carefully controlled lamination cycle. Cooling must be equally carefully controlled. Cost is high due to material and labor cost. Transline Technology is one of only an elite few PCB suppliers in the country successfully producing fusion-bonded boards today. The layup construction for standard lamination looks something like this. Copper-clad FR4 material that has been photo-printed and etched is layered or booked together with pre-preg between each layer. Pre-preg is made of reinforced or non-reinforced thermoset epoxy resin. When subjected to heat and pressure, the pre-preg begins to melt or flow. As the board cools, the prepreg cures, creating a permanent bond of all layers. This is the most common type of lamination used in the industry today. Standard lamination is typically used in digital and non-RF designs. In hybrid construction, a PCB is made with a combination of dissimilar materials. Standard FR4 is used on certain layers, while high-performance material is used on the higher frequency layers. The FR4 layers are bonded with standard prepreg. The high-frequency layers are bonded with bond ply that matches the properties of the material used. Multiple and often sequential lamination is required due to the dissimilar bond ply and complexity of design. The resulting benefit is increased performance, increased thermal control, and cost optimization. In hybrid lamination, the cost is higher than standard lamination due to the use of high-performance materials and increased labor costs due to multiple drill and lamination operations. FEP construction always uses high-performance laminates exclusively. The FEP film is very thin, very high-performing, and quite costly. Therefore, it is usually placed only between layers with the higher frequency and performance requirements. Bond ply or fusion bonding may be used to laminate together other layers depending on the performance requirements of those layers. FEP film is challenging to use for PCB suppliers. Subsequently, few suppliers offer this option. Caution must be used when working with FEP film. It must be laminated in temperatures ranging from 500 to 600 degrees Fahrenheit. This is very close to the temperatures used in the assembly process. If not carefully monitored, the reheating of the FEP film can result in delamination at assembly. In this illustrated example, a sequential lamination approach was used in combination with fusion bonding. The benefit of using FEP film is that it is very thin and a very high-performing bond ply. PTFE or Teflon materials are increasingly used in high-frequency RF as well as digital applications due to low electrical loss, consistent decay, and ability to tight thickness tolerances. In fusion bonding, adjacent layers of PTFE material are laminated together without the aid of any prepreg or bond ply. When subjected to pressure and extreme heat over a very lengthy and tightly controlled lamination cycle, the material begins to flow and bonds to itself at a molecular level. The encapsulation of inner layer circuitry and copper features, along with the absence of bond ply, maximizes the performance and has a homogeneous decay. However, the material and labor costs are higher than other forms of lamination. Fusion bonding provides the highest performance form of lamination available today. Transline has worked closely with the Rogers Corporation to fine-tune our fusion bonding process. Pictured here is a cross-section performed by the Rogers Corp laboratory in which they confirmed our success. A solid bond line and fully encapsulated copper features can be seen. This is a second cross-section, also performed at the Rogers Corp lab. Again, a good solid bond line can be seen, along with fully encapsulated inner layer copper features. Illustrated here are the four major types of lamination in order of their electrical performance, from low to high. Standard being the lowest, followed by hybrid, then FEP lamination, and finally the top performer, fusion bonding. Performance is impacted by both the material properties and lamination method used. Here is an illustration showing the cost impact of each lamination method. Fusion bonding being the highest cost, followed closely by FEP, then hybrid, and the lowest cost, standard lamination. Cost is impacted by a combination of material and labor cost associated with lamination type. This bar graph gives a generalized overview of the impact of each form of lamination. First, by performance, second, by cost, and third, by the number of PCB suppliers offering each method. As you can see, standard is the lowest performance method of lamination, moving upward to the highest performing fusion bonding. Next, you can see the lowest cost form of lamination is standard lamination, and the bars move steadily upward to FEP and fusion bonding, which are both higher due to material cost and labor. Lastly, you can see the green bar, which represents the available supplier base by lamination method. Nearly all PCB suppliers offer standard lamination. Fewer suppliers offer hybrid lamination. Only a small number offer FEP bonding, and only a few PCB suppliers in the U.S. offer fusion bonding. So how does all this information about PCB lamination impact you? Transline Technology is proud to be one of an elite few PCB suppliers in the country that offer fusion bonding. Furthermore, we routinely build hybrid and FEP boards for companies such as Lockheed Martin Aeronautics Skunk division. Our success in these advanced lamination technologies has been validated independently by the Rogers Corporation, as well as in our practical day-to-day success with our customers. This can potentially give you a major competitive edge in product performance when you use TTI, both in technological expertise and value. We have engineering resources available to help you address your specific design for manufacturability concerns in these advancing technologies, as well as your standard digital products. In this way, we put our team to work for you, saving you valuable time and overhead. In November 2010, Transline was recognized by Lockheed Martin Aeronautics Skunk division for 100% quality performance over the past 12 months. This division is known industry-wide for their advanced product development. We're proud of this achievement and are confident we can do the same for you. We hope you have found this information to be helpful and has clarified questions you have about lamination techniques. We're available to give this presentation live for your engineering, design, or product development team at your company's location. Please contact us to schedule an appointment. Transline Technology. Your innovation, our solutions.